So today we're going to talk about hyperbolas, and so these first few slides are going to be kind of like where hyperbolas are used. And so if you look at this first paragraph, it says when an airplane travels faster than the speed of sound, the sound waves form a cone behind the airplane. If the airplane is flying parallel to the ground, the sound waves intersect the ground in a hyperbola with the airplane directly above its center. A sonic boom is heard along the parabola, or a hyperbola. Excuse me. Here's another statement. Long-distance radio navigation for aircraft and ships uses synchronized pulses transmitted by widely separated transmitting stations. Okay, the pulses travel at the speed of light. The difference in the times of arrival of these pulses at an aircraft or ship is constant on a hyperbola having the transmitting stations as foci. So once again, another place a hyperbola is used. And then last but not least, the Pengrowth Saddle Dome. This is actually located in Calgary, and it is an inverted hyperbolic paraboloid. And basically what that means is that the level curves of the surface are hyperbolas. So this is kind of a picture of what that Pengrowth Saddle Dome looks like. Okay, and it's I think it's kind of like an arena, but it's not, you'll see. And so anyway, that's an inverted hyperbolic paraboloid. So what we're going to do is we're going to look at the equations for a hyperbola. Now real quick, we're going to make some observations. So you have this sheet of paper to look at. And first of all, we have a horizontal hyperbola. Let's look at the equation. Okay, so look at that equation. I want you to look at the vertical hyperbola, and I want you to look at its equation. What do you notice is different?
Horizontal has the x first and vertical has the y first.
Exactly right. Horizontal has the x first. Vertical has the y first. So this is the thing. With an ellipse, it didn't matter which one was first. With a hyperbola, it does. Whichever one is first indicates what direction the hyperbola opens. Because notice, there is also a subtraction sign in between. So with an ellipse, we had an addition sign in between. Okay? What else do you notice about the A and the B? Okay, they're both squared. Keep going.
They're both on the bottom and they're in the same spot.
They're both on the bottom. They're both in the same spot. So in the case of an ellipse, remember A was whatever one was bigger. In the case of a hyperbola, A is whichever one is first.
Wait, I thought A was the one that was with the x.
Nope. A is always the biggest one in an ellipse. In a hyperbola, A is always the one that is first. So A could actually be smaller than B. All right, the equation you need to remember is different than the one we learned with an ellipse. C squared equals A squared plus B squared. And last but not least, asymptotes. And you're probably wondering, well, what are those? Asymptotes are guidelines for how we draw our hyperbola in. So an example might be this one right here. If I were to draw my asymptotes in, that's what I would draw in, and those would be the guidelines for the hyperbola. Biggest thing to understand about the asymptotes, with the horizontal axis, it is B over A. With the vertical transverse axis, it is A over B. So those are different. So that's why I do let you have a reference sheet when you complete your test. So let's go ahead and look at the first one. We're going to look at two of these today, and then we're going to call it good. So it says name the center, foci, vertices, and the equation of the asymptotes, then graph. So from what you've learned with parabolas and ellipses, what would the center of this one be?
3, 5. Okay,
Negative 5, 3. 1. I don't know.
I'm America.
I want you to look at number
5,
1 on the board.
Oh, gosh.
What would the center of number 1 be on the board that I circled in brown?
3, 1.
3, -1. What's the
Yeah.
center
1,
here
1.
going to be?
1, -1.
-1, -1.
Not -1, -1, not 1, 1.
1, -1.
Negative 0 and 0.
0, 0. Why? Because nothing is done to the y, nothing is done to the x.
Dumb.
Okay? So, nothing is done to the y, nothing is done to the x. It's real similar to if you had like y minus 0 squared. Okay? So the center's at 0, 0. So I'm going to go ahead and put a star because that's where I start. So now, looking back at that reference area, is this going to open up, down, or left, right? Up, right. What? Up, down, y, up, down. It's going to open up, down because y is first. Okay, so it's going to open up, down.
Oh, I was just saying with the book.
Now, a in this case is 3, b is 5, because remember, a always implies the one that's first. And so now, here's my 0, 0. If a is 3, I'm going to go up 3 and down 3, because I know this is an up-down hyperbola. So now I need to figure out my foci. The foci go with what letter?
C.
C. Okay. And so from the previous slide, oops, I forgot to write the vertices. I'm sorry, we've got to write those in. So the vertices are located at 0, 3, and 0, -3. Now if you wanted to, you could write these together as 0 plus and minus 3, but you don't have to. Okay. So then now we got to find the foci. The foci are located at c squared equals
Bless you.
a squared plus b squared. So I'm, yep, so I have 9 plus 25, which is 34. So now let's take the square root of 34. What's the square root of 34? 5 point what?
5.83.
83. So what that means is that from the center here, I'm going to go up 5.83 and down 5.83.
Oh, we don't 0.83.
Well, we just approximate. So the foci, will be at 0 plus and minus 5.83. Now you could answer it as root 34 if you wanted to. Now the last thing I need to find is I need to find the asymptotes, and the asymptotes are the guidelines. Okay, so if I go back to that sheet, it said the asymptotes were y minus k equals plus or minus a over b. So basically this is what you're going to use. Here is going to be what y equals. Okay, this is going to be what x equals. So I have my plus or minus a over b and then times x. So if I would have had a quantity, that's what would have went in place of y and in place of x. So let's go ahead and,
I just missed something. Oh, 3
Okay.
and 5. Okay.
so now what I'm going to do is from the center here, I'm going to go up 3 over 5. I'm going to go down 3 to the left 5, and I'm going to go ahead then and connect those dots.
All of them?
Yep. Now, I'm also going to do the same thing, because remember it said plus 3/5 x and minus 3/5 x. So I'm also going to do a -3 over 5 and a 1 in the same direction. Yep, up 3 over 5. Good. So now let's go ahead and draw that line in, or that invisible line. That's why we're using a dashed line. And then last but not least, that is the guidelines for my hyperbola. So what I'm going to do now, notice how that is the lowest point on the graph, and I'm just going to extend it out so that it kind of hits the asymptotes. But yeah, so it doesn't actually touch the asymptotes, but it provides a guideline. So that's the first one we're going to look at. Now we're going to look at another one, And then, like I said, we'll call it good for today. Okay. Good. The center's at 0, 0.
Why? Oh,
And then,
So I'm going to put a star.
and it's up and down because the x is first.
It's what?
Left
Left and right because,
X is first.
yep, X is first. A is
That's
5,
That's in the ellipses, isn't it?
B is 4.
Or the other ones when
Yes.
it's up and down. Oh, this is awful.
So now what do I do from here? What do I do
Yeah.
from the center? What do-
5 over.
5 over and 5 over. Good.
Wait, why are we doing 5 then?
Because A is 5. Okay. So my vertices are at plus and minus 5, 0. What do I need to find now? Yep, so I'm finding foci, very good. So c squared equals a squared plus b squared is 41. So I know that c equals 6 point what? 6.40. So I'm going to go approximately 6.4 to the right, which you can't see the one on the right side because I ran out of room. 6.4 to the left. So my foci will be at plus or minus 6.40 and 0. You got to do the asymptotes. Okay, so the asymptotes in this case, if it opens left, right, it's b over a. So in this case, 4 over 5. So from the center here, I'm going to go up 4 over 5.
So I was right.
Down 4 to the left 5. Now one of the things you're going to notice is that the sides, or the points that we're putting in, will be the same width as the blue ones. Okay, so as the vertices. So there's your first set of asymptotes. Your next one is going to be this way and this way. So let's go ahead and draw those in. Now remember, they will always go through the center. Okay, those are our guidelines. Now what I'm going to do is just go ahead and draw my hyperbola in. Oops, that one got a little close. And there you go. So not too bad. So if you want to get a start, I don't know how many of these you're going to be able to do, but we will continue with this tomorrow. And here's your assignment, page 449. 2 through 8, the evens. 12 through 18, the evens. 23 through 28. And 34 through 52, the evens.